Let's look at question 82. Remove duplicates from a sorted list. In that question, you will be given a sorted list, and the task is remove the node if the node's value is duplicate. So in the example 1, in that example, we can say the 3 is duplicate, 4 is duplicate. So the final node only is 1, 2, 5. And the example 2 also show there is a 3, 1 in the list. So final result will be the 2, 3. So for that question, I think the key point is you should use several nodes to keep the status. So in the beginning, we have the list node return. That one will finally as a return value for the function. Then we also need node to keep the new list, the last one. And we also need the node to track what is the last one. So when we find, because we only after this node we can know is it valid or not, so we need to keep the previous one. We also need some count value. In the beginning is 0. We also need some variable to keep the previous node's value, so we can know the next one is duplicate or not. Okay, we have the while loop. We just reuse this variable head. If that one is not null, we can continue. If it's not, it's null, we just return it. So this one also can handle the node size is 0 situation. Okay. First, we need to detect the header's value is same as the previous one. Oh, here we need to, this one should be initialized to some special value is out of the range for the node's value. So here is the constraint side. The node's value is between -100 and 200. So we use the integer max values. Okay, if that one is equal to P, so it's just C++, we count is case 1, and else it means it's not same. Okay, if it's not the same, it means we find some new one, right? So if we find the new one, we need to handle the previous one. So we test if previous one's count is 1, it means that is valid. So we need to keep it. So before the keep it, we also need to check if the last is null. If the last is null, it means this is the very beginning one. So very beginning one, we set up this one. So else, the last next will be the new one, and the last will update to the new one. Okay, that is for case we find the count 1, and then if C is not, so in other case, this one means we find the new one, right? New one, so C will be the 1, and P will update to the new value. Okay, and after the loop, if the C is 1, okay, we should do the exactly same thing for this. here will be the yes here. Okay, if actually this is no needed, so just do that one and return it. So let us use the 1 1 1 2 3 to go through this code. So 1 is coming here, is not equal, right? However, C is a 0. So they only set C to 1 and the value to this one. Okay, we also forget to update loop here. We also forget update the previous node will be the head, and the head will be the header dot next. Okay, so then the second, okay, the one, we update this one, pointed to the first node, and the header will point to the next node, one. So next one coming, so the value is the same, so it's a C++. Now is a C becomes a 2, and the third one is 3. And then when going to the 2, 2 is not equal, but the C is 3, so we ignore this one, set up C equal to 1, right? The value is updated to 2. And then we go into the 3. 3 is not equal, but the C is 1. In that one, we first attempt to update the return value and also update this one. Now, last one is pointed to the 2, right? And then 3 is then we set up the C is 1, update the value to 3. Then the loop is end. We come to here. So the C is still is 1. We need to update the previous value. If now we do that one, so is we return value pointed to 2, 2 pointed to the 3. So we are done. Let us check the code. It's okay and submit it. Oh, we get some wrong one. Okay, so I say so in that one, the reason is every time we update here, right? We update this one. We need to cut down the next value. So the next one will point to here, right? So we still need this one here. And if the last is not now, we will let next become the now. Okay, and submit it. Yeah, so we are done. This one is just a go straight code, so the time complexity is big O of n, and the space complexity is big O of 1. Thank you for watching the video.